Assalamu alaikum, hi students and friends. This is your host and teacher Sayyid Ayazuddin Adar. You're watching Learn and Teach by Sir Ayaz. So I was doing O-level past papers and I've selected 5070 paper 22 and it's of October, November 2024. I'm done till question number 4. So I will continue from question number 5. Question number 5. A student adds large pieces of zinc to dilute hydrochloric acid. The zinc is in excess. A. Complete the equation by adding state symbols for the products. Zn solid plus 2HCl aqueous gives ZnCl2. All chlorides are soluble except lead, mercury, silver. Zinc chloride is soluble, so you'll write aqueous for zinc chloride ZnCl2. So I'll write AQ here. But what H2 exists in the gas state, so I'll write G for H2. B. Figure 5.1 shows how the volume of hydrogen changes with time as the reaction proceeds. Number 1. Describe how the shape of the curve in figure 5.1 shows that the rate of reaction decreases with time. If you look at this graph, you can see the gradient decreases as time increases. So you write the gradient decreases as time increases. Number 2, explain in terms of collision theory why the rate of reaction decreases with time. You see, you have as time progresses, the number of particles decreases and the particles also getting further apart. So the frequency of collision between these particles also decreases. So we will write particles get further apart. Particles get further apart. Frequency of collisions of the particles decreases. Number 3, the student repeats the experiment using the same mass of powdered zinc instead of large pieces of zinc. All other conditions stay the same. Describe and explain the difference in the rate of reaction when powdered zinc is used. So definitely rate will increase because powders have greater surface area and the collision frequency also increases. But you can even say there will be more collision per unit time. So I will write rate increases. Rate increases because powdered form have greater surface area, which means you have more collisions per unit time. You can even write collision frequency increases. C. Excess zinc is added to 16 centimeter cube of 0.4 mole per dm cube hydrochloric acid. Calculate the volume of hydrogen gas released measured at room temperature and pressure. Give your answer to two significant figures. Now, according to this reaction equation, we have 2 moles of hydrochloric acid and 1 mole of hydrogen gas produced. So, for your convenience, I am writing the reaction here. Reactant, that is 2HCl, giving 1 mole of H2 gas. Now, first of all, I am going to calculate the moles of hydrochloric acid. Moles of HCl. So, 0.4 mole per dm cube means there will be 0.4 moles in 1000 centimeter cube. 1000 centimeter cube contains 0.4 moles. Therefore, 16 centimeter cube contains X moles. Do the cross. So, X is equal to 0.4 multiplied by 16 divided by 1000. Sixteen multiplied by 0.4 divided by 1000. So 0.0064 moles. These are the moles of hydrochloric acid according to the relation. We have HCl and H2 here, 2 moles producing 1 mole. Therefore, 0.0064 moles produces X mole. Do the cross, it will become X is equal to 0.0064 divided by 2, which becomes 0.0032 moles. 0.0032 moles. Now, in order to get the volume of H2, they have mentioned at room temperature pressure. We know that 1 mole of a gas at RTP. RTP is room temperature pressure, occupies a volume of 24 dm cube. So you need to multiply these moles by 24. 0.0032 multiplied by 24. So the answer becomes 0.0768. 0.0768. Or you can even write 0.077 dm cube. This will be the final answer. Moving to next part, which is part D. The reaction of zinc with hydrochloric acid is exothermic. Complete the reaction pathway diagram in figure 5.2 to show the reactants and products. A labeled arrow for the activation energy EA, a labeled arrow for the enthalpy change delta H. Remember, for the exothermic reaction, reactants at high energy state than products. Which means in case of endothermic reaction, you have reactants will be at lower energy state than the products. So I will make a line here like this for the reactants, and for the product we have a line on the right hand side like this. In between these two will be having energy hump. This is energy hump for the activation energy. This is activation energy. It's going up. Remember, activation energy, the arrow must be going up. And as the energy is released, exothermic means energy is released to the surrounding, and product is at the low energy state. So the energy difference between the reactant and product must be shown in this way. Change in energy between reactant and product. Another thing, you have to write the reactants and products. So reactants, we have Zn2HCl, ZnCl2H2. Zn plus 2HCl, and we'll be getting ZnCl2 plus H2. Let's label it. We have EA for the activation energy and delta H for the enthalpy change. So this will be the final label diagram for this reaction. Part E, describe the observations made when a few drops of aqueous ammonia are added to an aqueous solution containing zinc ions. Now, zinc ions in aqueous ammonia gives white precipitate. So I will write down white precipitates. And in excess aqueous ammonia, when excess aqueous ammonia is added to an aqueous solution containing zinc ions, what will happen? It will dissolve or soluble to form colorless solution. Soluble or dissolves to form colorless solution. Next part, which is F, describe how to prepare pure dry crystals of zinc chloride after reacting excess zinc with dilute hydrochloric acid. So you have 3 marks for this. So you can write any 4 statements, any 4 from. Definitely you have excess of zinc in hydrochloric acid, so you have to remove excess or unreacted zinc. So first of all, you need to filter. Next point, wash the residue with distilled water. Wash the residue with distilled water. Then we evaporate through gentle heating. So that you will cool down or crystallize. Then you dry the crystals. Remember, for evaporation, you will evaporate the filtrate. You have to mention evaporate the filtrate. This point is very important. You have to write filter. You have to start with the filter because there is excess zinc. So then you have any 3 points from other 4. Question number 6. Figure 6.1 shows the structures of boron nitride and hydrazine. Boron nitride has a structure similar to diamond. You see the structure of boron nitride, it's like diamond. Diamond also have a structure like this. The only difference is that diamond, it's a allotrope of carbon, while boron nitride is a compound. It's not an element. So A, explain why boron nitride has a high melting point. Use the information in figure 6.1. So in the 6.1, they have already mentioned the structure resembles diamond. So you will start with this statement: giant structure and having many or strong covalent bonds. Giant structure with many or strong covalent bonds. B, explain why hydrazine is a poor electrical conductor. Use the information in figure 6.1. See the figure 6.1, you have hydrazine here. If you look at this structure, it's definitely containing covalent bond, and the structure indicates that it's a simple molecule. So it must not have any mobile electrons. So you write mobile electrons are absent. Mobile electrons are absent. C, complete figure 6.2 to show the dot and cross diagram for the electronic configuration of hydrazine. Show only the outer shell electrons. Now what I'm going to do, I'm going to show the key on the right hand side, which will help you to place the electrons, valence electrons for each of these, nitrogen and hydrogen. For nitrogen, I'm using cross. For hydrogen, I'm using dot. If you look at the position of nitrogen, here's nitrogen is group 5, which means it contains 5 valence electrons. Each of nitrogen atom having 5 valence electrons, while hydrogen, they have 1 valence electron. The proton number of hydrogen is 1. So each hydrogen atom, they are having 1 valence electron. So for the right hand side, 1 for this hydrogen, 1 for this hydrogen, 1 for this hydrogen. Now, for nitrogen, each nitrogen, we have to show 5 valence electrons. So 1, 2, 3, 4, 5. For left hand side, 1, 2, 3, 4, 5. So if you count the total number of electrons in each of these circles, for each nitrogen, it should be 8. 1, 2, 3, 4, 5, 6, 7, 8. For the left hand side, 1, 2, 3, 4, 5, 6, 7, 8. And for each hydrogen atom, there will be 2 electrons. Moving to next part. This is part B. The ionic equation for the reaction of nitride ions with water is shown. Here is the reaction: N3 minus plus 3H2O N3 minus plus 3H2O give NH plus 3OH minus. Number 1, the oxidation number of hydrogen in NH3 is plus. The oxidation number of nitrogen in NH3. Whenever hydrogen is non-metal, it must be having x plus equal to, so it must be minus 3. Not a redox reaction by referring to the oxidation number of nitrogen. Look at the oxidation number of nitrogen. It's minus 3 here or 3 minus here. So it's not a redox reaction. So it does not change or remain same. Per of and does not change or remain same. That is minus 3. Party. Boron oxide reacts with magnesium as shown. Reaction equation B2O3 plus 3 Mg gives 2B plus 3 MgO. 8 gram of boron oxide is reacted with 7.2 gram of magnesium. Show by calculation that boron oxide is in excess. Now you have two options, either convert mass into moles or use these mass in order to find out or prove that boron oxide is in excess. So I will going to write here either convert gram into moles or use the mass given, or use the mass given. Now for the moles, what I will do, if I want to find moles of B2O3, I need to divide 8 by MR of B2O3. So MR of B2O3. Here is B, 11 is the AR, oxygen 16. So 11 multiplied by 2, 16 multiplied by 3. So we have 22 plus 48. If you add up these, what you'll get? 8, 9, 10, 0, 1, 4, 5, 6, 7. 70. 8 divided by 70. MR will be 74 B2O3. 8 divided by 70, it becomes 0.114. These are the moles of B2O3. What about the moles of Mg? We have 7.2 grams. So now in this case, we need AR of Mg. Here is Mg. It's 24. So you divide it by 10, becomes 0.3. 0.3 moles of Mg. Now start comparing. Right in the reaction, B2O3 plus 3 Mg, which means 1 mole reacting with 3 moles of Mg. 1 mole reacts 3 mole of Mg. Therefore, 0.114 mole reacts with X mole of Mg. Do the cross. becomes x equal to 0.114 divided by 3. Sorry, 3 multiplied by 114. 3 multiplied by 0.114. And the answer will be 0.342 moles of Mg. Now compare these moles with the moles of magnesium. Here the requirement is high, so we have magnesium as limiting reactant, or B2O3 is in excess, boron oxide is in excess. So you write hence proved that boron oxide is in excess. Number 7, esters are represented by the formula CnH2nO2. A1, state the name given to a formula such as CnH2nO2. This is known as general formula. So you write general formula. Number 2, reduce the value of N in the ester propyl ethanoate. So propyl contains 3 carbon, ethanoate contains 2 carbons. 3 plus 2, 5. B, the ester ethyl butanoate is produced by reacting ethanol with butanoic acid. Draw the displayed formula of ethyl butanoate. So we have ethyl coming from ethanol. So ethyl group must be this 1, 2, and it's attached to butanoate through this ester linkage. We have oxygen, bond carbon, double bond O. Then we must be having 3 more carbons. 1, 2, 3. So this is the displayed formula for ethyl butanoate. C. Figure 7.1 shows the simplified structures of 2 molecules that combine to form a polyester. The top one must be diol. There are 2 OH group, and second one must be dicarboxylic acid. There are COOH group on both the ends. Figure 7.1. Number 1, complete the diagram in figure 7.2 to show the structure of 2 repeat units of this polyester. Show all of the atoms on all of the bonds in the linkages. Now, these will combine through condensation polymerization, and during condensation polymerization, there will be loss of OH from these diol and H from these alcohol. You can even remove OH from these dicarboxylic acid, then you have to remove H from diols. And this results loss of 2 moles of water molecule. Now I'm showing the linkage between these. So this one must be coming from diol. It will be joined through O bond C double bond O with this dicarboxylic acid. From the other end, we have again C double bond O, then O again attached to this blank box. Then we are again having O, C double bond O, C double bond O, O on this end, so on. This will be the final repeat units. Number 2, name the type of polymerization in this reaction. It's condensation. So I will write condensation here. D. PET is a plastic. Describe the chemical processes involved in converting used PET into a new plastic. Now we want to convert uh, the used PET into a new plastic. So simply you have to break it down into its monomers. So PET broken down into monomers. Then monomers repolymerized. Monomers repolymerized. In this way, you can convert this into new plastic. Ethanoic acid reacts with sodium carbonate. Number one, name the three products of this reaction. This reaction between acid and metal carbonate. So whenever you react acid with metal carbonate, you will get three products: salt, carbon dioxide, and water. In this case, the salt must be sodium ethanoate. So you write sodium ethanoate as one of the product. So other the two products will be water and carbon dioxide. Part 2. Ethanoic acid is a liquid at room temperature. Describe the arrangement and motion of the particles in a liquid. Simply in liquid, we know that the arrangement is loosely packed. Loosely packed, which means it's irregular or irregular. What about the motion? They are changing places, sliding over each other. Changing places or sliding over each other. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.